Hi there, this is Dr. Embody with Project 7. Now, Project 7 is dealing with lists of lists, and it's a game. It's this Connect game, and if you don't know the game, then you should really check out one of the links and see how it's played. You basically have this grid of I think it's 6 by 7, and you have these plastic pieces, and you drop them into columns. And what you're trying to do is get 4 of your color in a row. And so you ought to get a sense of that, how the game goes, and that because until you do that, this thing won't make sense. And what I want to talk about this time is the function that deals with checking to see whether you in fact did get 4 in a row. Now, it turns out that in this particular problem, we have a fixed defined grid. It's 6 by 7. So because that is fixed, it's not a variable, so our program doesn't have to take advantage of a game that's longer or taller or whatever. We get to take advantage of that because we know exactly how big it is. And so if you have that constraint, you can now in this case we can figure out diagonals by enumerating all the possibilities. And that's a type of approach that novice programmers don't often think about. Sometimes the best thing to do is kind of do the simple, do it out, try all the list all the possibilities. So let me, with that brief introduction, let's take a look at this. All right, so we're playing this Connect 4 game. And just like with other projects we have oops, so we have so in this case we don't have opening a file. But we're going to initialize things. We're going to have a function for choosing colors. We're going to have a we're going to be able to display the board, but we actually provide that function, so you don't even have to worry about doing that. And then then we're going to drop it to a function that drops a disk in. So when you look at how the game works, in this case I've got B's and W's for blacks and whites. If in fact I drop a disk in, it will go all the way down to the first empty space. And so that's what's going on with that function. Then here is the tricky one. I want to check that I in fact have 4 in a row. That is a winning sequence. So for example, there's a bunch of them here. There are 4 W's in a row here. There's 4 W's in a row there. There's and then and here I have 4 blacks in a column there, right? And then here's 4 whites that are in a diagonal. So how do I go about checking this? Well, what you want to do here is it's pretty easy to check all the ones in a column, but the diagonal is a little trickier. Now, what is the setup here? Well, the way we do this is we're going to create a list of rows. So we'll have the first row, and we'll have the second row, and so on until we get to 0, 1, 2, 3, 4, 5, until we get to row 5 if I'm starting in 0. And of course, one of the things that we have to do is convert from the real world of 1 to 7 and 1 to 6 into our how it's represented internally, where the counts start at 0. So each row then will have 7 items in there, right, representing all 7 values that you can have. And so we have a list of lists. And each of these lists is a row. So any particular column, so for example, if I wanted this column, which of course is at index 2, then that will be the third item, or the one at index 2 in each of my rows. So this is the third item, or index 2 of each of the rows. So you need to get a little comfortable with this. But now, how do I in fact check these guys? Well, this is a case where I have the same color in the same column, so it's if I want to check a column here, what am I doing? Well, this is column 0, and my indices go from 0 to 5, so I can think of this as checking these coordinates. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and 0, 5. Those are the coordinates of these guys. And if I make this as, and if I were to call this something like my row 0, I can now go and check each of these coordinates on my board and see if I have 4 in a row. Well, fortunately, there aren't that many of these, right? There's 7. There's, oops, I'd said that wrong. That's actually column 0, not row 0. Let's fix that. That's column 0. Right, and so I can do column 0 and column 1 and so on all the way across. Those would be my columns. So I can make lists for each of my columns. I can make lists for my rows, and then I can also make lists of diagonals. And there aren't that many of them. I mean, there's quite a few of these, but there aren't that many, and you'll want to do those. So to check to see if there are 4 in a row, you just need to check these lists that you make of the coordinates for the columns, the rows, and the diagonals to see if in that you have any that are 4 in a row. The other thing that's important is, how do I index any of these? So if I called my list of lists L, that's a terrible name, but it fits in here. If I want to get to a particular element, let's pick this one right here. All right, that is at on column 2, and it's row 0, 1, 2. So that's also column 2 and row 2. So how do I index that? Well, where's row 2? Let me pick a different one. That's a bad choice. let's in fact, let's do a different one. Let's do this guy here. So at least I'll have indices that are different. So where is that? That's in column 3. And it is in row 0, 1. So now I'm in column 3, row 1. Well, what's row 1? Row 1 is this guy here. So that would be L, row 1, and within row 1 we are in the 3rd column. So there's the index, the row and the column of this guy right here. And then the question is, what's there? Is it a blank, or is it a B, or is it a W? So we're indexing into the list this way, and so these are my coordinates of that I'll need to be checking. So you'll basically what you'll do is you'll make all the possible coordinates of your columns, rows, and diagonals, and then using this kind of indexing, go through them to to then check to see what values you have and count them up to 4. You got to be a little careful because you can't simply say, are there 4 B's in a column, because they got to be 4 B's in a row, right? So you can't have like B, W, B, B here. There's 1, 2, 3. There's 4 B's in this column, but there aren't 4 in a row. So you got to watch out for that, right? And similarly, it also doesn't work if you have B blank, B, B, blank, B. Okay, so you've got 4 B's in that row, but they aren't together. So you've got to be careful with that in terms of how you're doing your counting. And so this is actually this particular function is the hardest one to get right. There are tests. There's a gazillion tests there, and we break it up into 2 parts. There's one set of tests that are just checking the rows and columns, no diagonals tested in there, and then the second test now adds in the diagonals. And so this will give you a chance. Don't even think about diagonals first. The first time you write this function, just handle the rows and the columns. You get that right, now you can handle sort of the messiness of the diagonals. Do that one first, and then once you got that going, do that, because we do have separate tests for those, just to kind of help you out to do this in pieces. So a lot of scratching there, but hopefully that gives you an idea of how to think about solving this part of the project.